Okay, with reference to what we discussed in our previous lecture, we are going to solve a number of problems. So remember, these were indeterminate, these were determinate, and then I said that this was very important to remember. All right, so let's start. Okay, so what happens here? All right, so we check quickly to see if we have the indeterminate forms. Okay, so here we'll have 100 and then infinity plus infinity squared plus 5 will give us infinity. So the situation we have here is going to be 100 over infinity. Okay, 100 over infinity is not indeterminate, so we can solve just like this. So this is going to be 100 over infinity squared plus 5. So this is going to be 100. Okay, this is going to be 100 over infinity. Because this is infinity, then plus 5, it will still be infinity. So examples we did in our previous. Then we said that this, as you're going up, this is tending towards 0. Why? Because remember, we have this situation here. So then this gives us 0. So the limit of this function, as you're approaching 0, as you're approaching infinity, it will be 0. What about this one? What happens here? We check quickly. This is the constant, and then this one will be a large number, an infinity, but negative, and then this added to that infinity is insignificant, so this will still be infinity. So what happens with this? What happens with this is that we're going to divide a constant by an infinity, albeit negative. So this becomes, when we're replacing values, we don't need to show this. So here we can have 7 negative infinity cubed minus 10. Okay, so now what are we going to say here? We're going to say that this is 7 over, this is negative infinity minus 10, this minus 20. Okay, this we're going to say that it's still minus infinity, so it's going to be minus infinity like that. Okay, now what are we going to say here? Are we going to say this is 0, or are we going to say that this is what are we going to say? Negative? What are we going to say here? It's the same. This is just a negative. As within number, we can factorize it. Okay, and then we have 7 over infinity like that. This, we know that it's in that form because we can take this, put it here, and then the 0 comes there. So we know that this gives us a 0, so negative 0, which is 0. So the limit of this one, as it approaches negative infinity, is going to give us 0. What about this one now? What happens here? Now what happens here is that we're going to say that we try either in our heads, or we can put it somewhere to say that this is going to be infinity. And what about this one? That is going to be infinity as well. Now we can go to our list and check. So this one is which one? It's this one. It means that it's indeterminate. We can't know the solution here. So to say that we are going to try and change something here so that we make it into any of these. So what can we do here? I think that we are going to try and factorize. Okay. So 3x minus 100. Now what has happened here? What has happened is that we have this infinity here, would be that. This is something that can also give us infinity. So here we have infinity times infinity. So now we can say that this is what we end at. So we can say that now we can replace the values here, and then here we're going to say 3 infinities minus 100. So this is going to be infinity, and we said that this is just a bigger infinity, but it's still infinity minus 100. And we said if we remove 100 or any number from infinity, it will still be infinity. So this is infinity times infinity, which is here. Now, what did we say the value was here? The value we said here is infinity, here is infinity. These gave us 0, and this gave us minus infinity. So we need to remember the values of these ones, because these we can have values. So now we can say that this is going to be infinity. Okay. So now if it's ending at infinity, what are we going to say? We will say that the limit does not exist, because it's going and going and going. Okay. What about here? What happens? We check quickly. So we put negative infinity here, but whatever, if it's negative and you give it an even power, we know that that will give us what? That will give us a positive. So this is positive infinity, and this is positive infinity. Okay, and then that is 1. So we can tell that here, whatever we do, we're going to end up at here. So we can continue and replace that. So we'll say negative infinity, 4. Okay, now we're getting the value, so we can remove the notation there. Negative infinity as well, 2 plus 1. This is insignificant because we're adding to infinity, so that becomes infinity plus 1. So now we're saying that this gives us what? Gives us infinity. Now, when you have infinity like that, we can say that obviously this is not indeterminate, because we could actually determine the answer, which we got here. But we can also now just say that the limit here does not exist. Why? Because it's going away from numbers, so it's going towards infinity. So this does not exist. Here's another one. What are we going to think about here? First, we test. As always, we need a strategy. So we test. Are we going to have it here? Are we going to have it there? All right. So what are we doing here? Okay. What are we doing here? We are going to check this first. Right. So here we can say that this is going to be infinity, albeit negative infinity, and that's going to be infinity as well, negative infinity. So it's negative infinity over negative infinity, then we get this one here. Okay. So if we can get that one, we are going to say that it's in determinate format. So what are we doing? We're going to try and remove that situation. So the strategy for removing that is, you'll see now, we can say X. So you have to be very good at seeing these patterns or tricks and patterns. So here we're going to say we're going to remove this and create that format. Okay, so it's always any of these three. If you're not here, you're working from here. If you're not here, you're probably working from there. If you're not here and there, you're probably working with this one. So we're working with this format here. We're trying to target this. So here we're going to say that we're going to divide here by x, there by x. Or we're going to multiply by 1 over x and 1 over x. So I can say I multiply throughout by 1 over x. Then I multiply throughout by 1 over x at the bottom. So if I did that, I'll have x over x plus 7 over x. Then what about here? Here we'll have 3x over x, then plus 5 over x. Remember, we're not dealing with 0, we're dealing with infinity. That's why we are approaching this different. So we're going to remember our notation because we haven't replaced the values yet. That is something to remember. So this one will give us 1 plus 7 over x. And what about this one here? This one will give us 3 plus 5 over x. Okay, now if we replace with negative infinity, we are going to get this, where we get 0. Okay, so we can now replace the values. We're going to say 1 plus 7 over negative infinity over 3 plus 5 over negative infinity. Okay, now when we get here, it means that we actually can get the values now. So this will be 0, that will be 0, leaving us with 1/3. That will be the limit. Okay, right. Okay, so as usual, what's our strategy? We check if we replaced infinity here, we get infinity. If we replaced infinity here, we get infinity. So this gives us infinity over infinity. If it gives us that, what is our target? Can we immediately find it here, or do we go with the third option here? We actually go with the third option. But how are we going to reduce this? How are we going to reduce this? It's by multiplying by the highest. Usually it's the highest power. Okay, so here we're going to say 1/x², then here as well, times 1/x². So we're going to say limit x approaches infinity. So here we're going to have 7x² plus x/x² minus 10/x². Then at the bottom, we're going to have 2x² minus 5x/x². Okay, what does this give us? It gives us limit as we are approaching infinity. We're going to have this one cancels out, so we'll have 7 plus, what about this one? This will give us 1/x. What about this one? This one will give us 10/x². What about at the bottom? We'll have 2 plus, this one will be 5/x. Right, now we can replace our value, which is infinity. Okay, now when we replace with that, we'll have 7. This is similar to this. Okay, so we can say that this is 0. Okay, that's second portion. This will be similar to that, so we can say -0. Then we can go here and say 2 plus, this will be similar to this one, this here, so it will be 0. This ends up at 7/2. That will be our limit. Alright, how about this one? So if we replaced infinity here, we're going to get infinity. How about here? We're going to get infinity. I hope that now we know why, because if this is infinity, I take away some form of infinity, we'll still have some infinity there that we don't know. Even here, we'll have that same situation. In fact, this one quickly gives us indeterminate form because we'll have infinity minus infinity here quickly. So in many forms, this one will be indeterminate. So what do? We try to apply this concept. Okay, so we're going to divide or multiply throughout by the highest power. So here it will be times 1/x3 times 1/x3. Right, so we maintain our notation as always. You can't be lazy there. So this one will become 1/x. Once that comes in, this one will become 3/x². This one becomes plus 7/x3. Right? What about this one? This one becomes 1. What about this one? Becomes plus 10/x². This one becomes 4/x3. We're ready to replace with our values here. This one is 0. This one is 0. This one is 0. Why are these zeros? Because we have this format here. X divided by infinity is 0. Our x here happens to be a 1 divided by 0. That divided by infinity, that's 0. Here our x happens to be 3 divided by infinity, we get 0. Same thing here. And so we go at the bottom, here we'll say 1 plus, this gives us a 0, that gives us a 0. And so here we know that it's 0 over 1, and this is normal arithmetic. So this will be 0. So this limit exists and it's 0. How about this one? This one is a bit tricky, okay, because if we get this, we replace there, that's infinity, that's negative infinity. Okay, so we find that. And if we're to continue here, we'll find infinity is there, infinity is there. So it gives us this format, gives us that format. Okay, so we know that we cannot proceed and just get and replace there to get the values. Okay, so what do? What we're going to do here is we are going to try and make this format. How do we make it? We're going to say limit x. I'm sure by now it's becoming a little bit boring for you because you know what's going on, but we can practice together, right? So here we're going to multiply by the highest power, which is 1 over 2. This is 1 over x2. So this one gives us 7 plus this will be 1 over x. What about this? That will be 11 over x squared. So practice as we practice so that we can master this. And then this one becomes 1 over x squared minus this one, 1 over x. 4 here. Now, if you can't remember why we are multiplying here and there, it's because this has got integrity. This equation here, or this expression has got integrity. It's intact the way it is. It's like if I have 1 over 2, I can't now come and multiply by 2 only here. If I did that, this becomes 2 over 2, which is 1. But if I came and said that, it means that I'll have 2 over 4, which I can still bring back to here. And this is the reason why, because we know that this and that gives you 1, and this gives you 1. So it doesn't change the integrity of that equation, expression rather. Okay, so now we can go on and insert our values. So we'll have 7, and then we'll have 0, and we'll have 0. Reason being that we are following this one here. Okay, and then here we can put infinity here, and then we'll get a 0, and then there we'll get a 0. So what do we have? We have 7 over 0. Okay, and so this is not any of these. It's different. It's not any of these, right? So what does it mean? Okay, what does it mean? It means that we can still look at this in detail and see where it's going to go, especially the denominator. Where is it tending towards? But we can already just look at this, okay, or this one here, to say that once we are dividing by 0, since these are limits, we can say that this tends towards infinity. Okay, so this is the resulting limit that we can work out here. Okay, I hope we've understood. If we assessed this one deeply, we are going to still find that it's actually approaching infinity. Our strategy is the same. Another problem, same strategy. We check if we inserted our limit here, our x value, where is it going to tend towards? So this would be infinity, that would be infinity. So already inside this radical sign, we have infinities, okay, dividing each other. So we're saying that this is indeterminate. How are we going to fix it easily? Are we going to factorize and all that we used to do? No. Are we going to, because we can't factorize it, are we going to see that it's already in this format? How easy would that be? No. So we'll try and create the last format. So we're going to say limit x approaches 0 or infinity rather. Then we have this. Okay, we're going to divide by the highest power, which is 3. Okay, so we are multiplying here 1 over x3 then times 1 over x3, right? So here we'll get 1 plus, see that? This will be 7 over x2. Remember we said that simplification is probably one of the most important things in mathematics, so we gave examples. We need to visit that if we're not very comfortable with this, because you know all precalculus is coming together now to help us here. All right, so here now, what are we going to do? We're going to say that this will become, now we can replace the values. So the values here, we can say that we have still the radical sign. We'll have 1 plus this one, we said it gives us 0. Okay, and then we say that this one will give us 4 plus 0. Okay, so this now becomes 1 over 4, which is 1 over 2. That'll be the limit. Okay, let's look at another example. Let's have a look at this one. So if I took infinity and I put it here, take infinity and I put it there, I'm going to end up at B. So in determinant form, we can't work with that. So we need to see, are we going to come here? Are we going to go there? Well, let's see. How am I going to multiply with anything here and still maintain the integrity? Because it's just one equation here. If I multiplied with, let's say, 1 over x squared, okay, it'll be something else, because once it goes inside here, it'll be x4. There'll be something else. And then if I said I divided by 1 here, so that I maintain the integrity, let's say I have 1 over x squared, and then I have 1 over x squared. The trouble is that this one comes back to the top. So meaning that we are just going to go around a circle. So that we cannot do, right? So what are we going to do? We're just going to see if we can use the conjugates. Now, I'm going to leave this out just for now. We'll put it back. So here it's going to be because these radicals, they can be a problem sometimes. There's so much that you're carrying with you, so much so that it's easy to leave something out. So we want to reduce clutter when we are working with these. Okay, so I'll leave this out for now, just to resolve this first. Now here and there, what do we have? Here and there, we're going to say that this is difference of 2 squares. So this is going to be x squared minus, I'm going to square this, x squared plus 7, and then we'll square this like that. Then we know that this now will become our denominator. Right, so this will be x squared plus 7. What is the next thing that we do? X squared minus this one, this, and the radical sign, they cancel out. So we have x squared plus 7. What about here? That we maintain plus root x squared plus 7. Right, so what will happen here? I'll put it here to conserve space. This one and that one go. So the final form of this one becomes 7 over x plus that x plus 7, x squared plus 7. Now we have reached where we can bring back our limit. Okay, so now we can insert it into here. Now carefully, we can say that 7 is maintained. I'm going to have infinity plus infinity. Is it a problem? No, because we are saying that we can find the value. So infinity plus infinity will give us infinity plus infinity, because this will also be infinity. So this will be 7 over infinity. Now we can look at this third option here and say that this is 0. Okay, you always find your solutions by checking here, checking there, or checking here at the bottom. Okay, let's quickly do our assessment. Our assessment for this one will be, if we put infinity there, we have negative infinity. And then if we square this at infinity, we'll get infinity. It was negative, now it's positive. Infinity plus 7 becomes infinity. So we take away infinity. This is our situation here. Where does it fall? We come here, we check, it's not there. We check here, it's there. What's the value? That's the value. So we are ready to go. We can say this one will be negative infinity minus negative infinity squared, like that actually. Okay, like this, then plus 7. So this one will be negative infinity minus, this becomes positive infinity plus 7. It's very important to show steps. Okay, so here we have infinity, square root of infinity. Then here we're going to have negative infinity, take away infinity. This, we say that it gives us that value, which is negative infinity. Okay, so this is our end. Obviously, we now can say that this limit does not exist because it's tending towards a number where we can't stop. Okay, so these are the examples that we had to look at. Now we are going to go to we're going to begin our journey towards the other big portions of calculus. So we're going to begin to look at differentiation, and then we'll go to integration. Okay, all right, all the best.